but I'm sure that'll cause havoc later. So contain 14, that'll be important, right? The increasing function W models the total amount of solid waste stored at the landfill. Planners estimate that W will satisfy the differential equation. Nice. So W models the total amount of solid waste stored at the landfill. Planners estimate that it will satisfy the differential equation for the next 20 years. W is measured in tons, and T is measured in years starting from. So it starts at 2010, and at 2010, how much waste is there? 1,400, right there, exactly. Does that make sense, everybody? So we have T and the amount of waste. Nice. Use a line tangent to the graph at time equals O to approximate the amount of solid waste that the landfill contains at the end of the first 3 months. T is in years, correct?
Yeah.
So,
T is 0.
Oh, a T is 0. Thank you very much. That's a great thing to notice. T is 0. Absolutely. So, hey, it even tells you T is 1/4. Isn't that nice? I would imagine that by not saying that, there'd be like 5% of people would just put in T equals 3 months. They put in 3 months, right? They put in 3. So what's the, you're using point slope form, y minus y1 is equal to m times x minus x1. So in this case, what are you going to write? You're going to write, what's the, which one? Y minus, okay, you could do y minus 0, sure. Equals, what's the slope? Oh, wait.
It's minus 11.
How do you figure out what it is? You plug in what where? You plug in something to this, right? You plug in W equals what? 1400, right? That's the slope you're looking for. So the slope you're looking for is 1/25 of 1400 minus what? 300, right? Correct. Times x minus
x naught, which is 1.
Okay, so kids, so x1 is going to be x minus what? 0, right? Is everybody okay with that? So what should go right here? 1400, correct?
Yeah.
So this is our tangent line. So what do we have here? Y minus 1400. What do we get? 1100. So it's going to be 44x. So if we wanted to translate this back into T and W, this right here is what? W, and this right here is T. So W is equal to 44T plus what? 1400. So it asks us how much waste will be there at time equals 1/4. So W at, and I won't use the line there, sorry. W at 1/4 is going to equal 11 plus 1400. So what's that going to be? 1411. Nice. 12, right. So if you want the second derivative here, you want this right here. You're differentiating. Again, what do you end up with? 1/25 what?
W.
dW what?
dt.
dt plus 0, right? Because the constant goes away. But you're solving, you want it in terms of W, but what is dW dt?
125 W minus.
Correct. So you know that this right here is going to be 1/25 squared times 300. Are we good with that? Because what do we know? We know that this right here goes where? Right there. It kicks out at 125. Are we good? Let's see how we did. Are we pretty confident in this one? What do we think?
He's asking if it's
Oh, and then so it says, to determine whether your answer in part A is an underestimate or an overestimate. Well, this tells us what? Well, this tells us the concavity, right? So we're looking at, we would love to know the second derivative at what value? When T is what? 1/4. And that's going to, when T is 1/4, or what do we want to plug in T as 1/4? Oh, we have it in terms of W, right? So our W was what? 1411 at that point, right? It was 1411. Well, the concavity is going to be what? The concavity is going to be positive, right? Look, you're going to have, it's not, when time is 1/4, you want it when W is equal to what? What was our estimate?
Oh, that's 300.
It's right, 300, right? Like this, right? So what's that going to be? We don't care what it actually is, but this is just going to be, it's going to be a 1, 1, 1, 1, right? Which is greater than 0. So what does that mean? Concave what? Concave up. So tangent line is what? Tangent below. So our estimate is, so underestimate. Does that make sense, everybody?
Yeah.
Look at that. We've done 2 of these so far, and has concavity come into play with regards to asking you whether your estimate is above or below. It's coming up twice. Earnness. So look, you have dW dt is equal to 1/25 W minus 300, right? We want W, we're looking for W in terms of T, right? So what do we have to do first? There's something you have to do first on these. What'd you say? Separate. You have to separate variables. If you don't separate variables, you get like at most 1 point on this section. It says like 1, separate variables. So dw needs to be attached to w, right? And dt needs to be attached to t if it was there, right? So what are we going to do on this? What should we do? Tell me what I should do.
Find dt on both sides.
Sure, you could have dw is equal to 1/25 w minus 300 times what? dt. Now what?
Divided by minus 300.
W minus 300? Okay, so you have 1 over w minus 300 dw is equal to 1 over 25 dt. Hey, we separated variables. Nice. So now what do?
Integrate both sides.
You integrate both sides. So what's the left side going to become? ln
So
of
value of
w minus 300. Thank you. Like this. Thank you so much. And what does the right-hand side become?
1 over 25.
1 over 25t plus some constant. Nice. But what are we trying to isolate?
W.
W. So we know that e to the 1/25th t plus c is equal to what? W minus what? 300, like this. And this is the same thing as e, just so you can remember your exponent rules, this is something like e to the c, right? And what are you just going to call this? Call that like a is a common thing to call it, right? So equals w minus 300. Well, w is increasing, so what can we do with that absolute value?
Take it out.
You can just take it out because it's never going to come into play. So you have a times e to the 1/25th t equals w minus 300. So w in terms of t is now a e to the 1/25th t plus what? 300. Are we done?
No.
No, we need to solve for a. So we know that w of 0 is 1400, right? So we know that 1400 is going to equal a e to the what? 0 plus 300. What's e to the 0? 1. So you get a is equal to 1100, right? So what do you now have? W of t is equal to 1100 times e to the 1/25th t plus what? 300. Like that. Now, you always check, did we answer the question completely? Let's check. It says, find a particular solution. Is that the solution? There it is. 5 points, couple minutes. Look at this. Take a look. Did we crush it?
Yeah.
Totally. You totally crushed this. When you see these, separation of variables should make you super happy. Super happy because look, they do 5 points condensed into there and they can't give you anything too clever or it'll totally break apart the consistency of the answers. Like they literally, in the question in part A, they told you 3 months is 1/4 of a year. Like that's them. That's them testing this question out and realizing that way too many kids were doing the right calculus with 3 instead of 1/4, right? That's awesome. So when you see separation of variables, be like, hallelujah, do it.
Oh, this kind of problem.
Okay, so for the first one, for A, it says find g of -3. So this is just a plug-in one, right? 2 times -3 plus the integral from 0 to what? Of f of t, right? dt. And this is graph of f of t, right? Nice. So what does this mean? It's going to be -6 plus the integral from 0 to -3. So what region are we looking at here? This, but are you going left or right? So that's above the axis, right? But you're integrating from right to left. So it's the opposite of that, which is positive. So it's going to be negative, right? So it's a quarter circle. So it's 1/4 pi times 3 squared because that's the radius. We with me so far? 9 pi over what? So what do you have to do with that? You have to then not add it. What is it? Subtract what? 9 pi over what? 4. And then it says find g prime of 3. So what fundamental theorem of calculus do you get to use?
Second fundamental theorem of calculus.
Second? I don't know why this is not letting me do this. Okay, there we go. So because it's integrating from 0 to -3. See how it's going from... It's going backwards for something that's above the x-axis. So if we want this, if we want to find g prime, what is it? G prime of x? G prime of x is going to be what? 2 plus fx, right? So that's a second point. Like this is 1 point on this question. This is a second point on this question. And then what's the third thing asking for? G prime of 3. G prime of 3 is going to be 2 plus f of what? 3. So how do you find that? You go back up here.
Oh, it's negative 3.
Oh, negative. Thank you very much. Is it negative on the question?
Yeah.
So how do we do that? Do we just go up here?
Yeah.
What is g of negative 3? 0. So this, we think this is going to be 2 plus 0 equals 2. And that's probably a third point. Let's just check this. What number is this? Yeah, check that out. How do we do? This is, do you understand the basics of the fundamental theorem of calculus? Do you? Hopefully. Okay, let's move on. B asks us, determine the x-coordinate of the point at which g has an absolute maximum. You always have to answer these really carefully. Determine the x-coordinate of the point at which g has an absolute maximum on the interval -4 to 3. How do you find where something has an absolute maximum? Yeah, Henry?
Well, first you find just the maximums, period. You probably find the derivative of g.
Why do you need the derivative to find the maximum?
Because then you solve for 0.
Why? I want the y first.
What?
You're telling me all the work, but why are we looking for where the derivative is 0?
Because that's the maximum that the derivative is going to be equal to 0.
That could be where it happens. Yes, absolutely. So we're looking for potential places here. Yes. Yeah. Okay. How about this, James? Once you've written it down, then raise your hand. Okay. And where that equals what?
0.
So when this is true, 2 plus what?
So
when does f of x is equal to what?
-2.
So what do? You go back up here.
Find the slope.
Yeah. So where does f equal -2? Well, the only place that potentially could happen is where?
2.5.
Like this.
Yeah.
So we have. It tells us it's a line, right? So we know if you just do the basics, what's that going to be right there? 5/2. Is that correct?
Yeah.
Okay, so here's the deal though. So that's a critical value, but what do you also have to check?
The endpoint.
So remember that g of x is defined as what? Let's just take a look at what g of x. What was g of x? It was 2x plus the integral from what? 0 to x of f of t dt. So it's 2x plus this integral, right? Plus this integral. So you look at this and say, you look around this point. What's happening after that point? After that point, it's collecting the value, the area under this curve, which is a line. Is this area going to be counted as negative or positive right there? Negative. So it gets here and then it goes down. Do you agree?
Yeah.
It does go down, right? What happens when you go backwards from here? When you go backwards from here?
You go less negative. You start to lose the.
So it's going. So basically the point is this the maximum? What do you think?
We can test it.
We could test it. How do we test it? What do we compare it to? What do we plug in?
Yeah, we plug in.
Plug in.
-4 and 3.
Why do we also plug in -4 3? Because those are the endpoints. So we know that it could happen at 5/2. So let's actually find the value at 5/2, right?
Yeah.
So what is g of 5/2? Can you actually figure this out? Yeah, it's going to be 2 times 5/2 plus the integral from 0 to 5/2 of f of what? 5/2? Oh, f of t, sorry, dt. Right, exactly. So what's this? It's going to be 5 plus, and can you actually find the integral from there to there? So you're looking at this right here, correct? And then you're taking this, that's positive because you're going from 0 to 5/2 plus this right there, which is going to be positive or negative. What's the area inside here?
2/9.
That's what is that? 3/2 right there. This is 3. It's half of 9/2, right?
Yes.
So it's going to be 9/4. Is everybody okay with that? This base right here, how wide is that? That's 1, right? And how far down did we say it went? It went down 2, right? So what's the area inside there? 1/2 base times the height. So it's going to be what? -1?
Yeah.
So if you add these two things together, what do you get? You take away 4/4, so you end up with what? 5/4. So let's go back down here. Sorry, I'm trying to mix all this together. So it's this minus what? 5/4. So what do you end up with there? 25. What? 20/4. Like this.
Isn't it positive?
Oh, it's positive 5/4. Thank you. It is positive. Excuse me. You're absolutely right. Sorry. So what is it going to be? Not 20/4. It's going to be. What is it? 25 plus 5 is what? No. Well, this is 25/4. Thank you. Thank you. I can almost do basic math today. So we tested our critical value, but what else do we need to test? Endpoints. So we should also test g of what? -4 and g of what? 3. So g of negative 4, and I'll pause. It's a change in
Concavity.
concavity. So you're looking for when, we'd love to know when g prime of x is equal to 0 so we can know when it changes sign,
G double.
right? Do we have g prime of x?
What you mean G double?
Yes, that's what I wrote right there. So what we have g of x. Did we already find g prime of x? What was g prime of x?
2 plus f.
2 plus f prime of x, right?
2 plus f of x.
2 plus f of x, thank you. 2 plus f of x. So what is g double prime of x? F prime of x, right? So we want to know, when does f prime of x equal 0? So we go back up here. Sorry. Where does f prime of x equal 0?
It's not that clear.
No.
It's not that clear.
Is it
Yeah,
zero?
because in
Is that corner? So
Well, where do you want to say it's equal to 0?
0.
And no, it is not, because at x equals 0, it has this split.
X equals 0. Exactly. What's that called? It's called
It's called a
kink.
right?
Yeah, it changes instantaneously, right?
Yeah.
So here's the thing. It goes from a slope of 0 all the way up to like positive infinity, right? And then it goes back down to 0, right? But then it immediately jumps from 0 to what? This is down, what? 3, 4, 5, 6 over 3. This is a slope of negative 2, right? So it goes, you have every slope from 0 all the way to positive infinity, back down to 0, and then when does the slope instantaneously become? Negative. What does it jump over? It jumps over negative 2/7. The derivative function is not continuous. The left-hand derivative is not equal to the right-hand derivative, so therefore it's not continuous. Theoretically, could the mean value theorem still be satiated? Theoretically, right? Like the average rate of, like if we move this up a little bit, if we move this endpoint up like up here,
Yeah, you make
it would still satisfy it, right?
Yeah.
But so what? That's not what it's asking.
I can find the line.
I can find, okay, it goes upward.